Yes, students. So, in this class, our first chapter is real numbers. So, today we are going to discuss about real numbers. So, before, say in 6th class, 7th class, 8th class, 9th class, so we learn about number systems. So, what are the number systems in previous classes we discuss? So, many number systems we discuss. So, first we discuss about set of natural numbers. Set of natural numbers, what are the set of natural numbers and what are the properties, all this we discuss in previous classes. Then after that, in very next class, what we discuss about whole numbers. So, whole numbers, about whole numbers we discuss. So, what are the properties of whole numbers? So, what are the whole numbers? What is the set of whole numbers? Then how to represent whole number set. So, then after that, what we discuss? Integers, set of integers. So, what are the set of integers? So, what type of numbers there in set of integers and what are the properties? Then how to compare the numbers, means less than, greater than, which one is a less and which one is a greater and which one is a equal. So, how to say which one is equal when we compare negative with negative, negative with positive, then positive with positive, negative with 0, positive with 0. So, which numbers are greater, which numbers are less, and arranging in ascending order, descending order, and addition, subtraction, multiplication and division properties we discuss in integers. And then after that, we discuss about rational numbers. We discuss about rational numbers and also we discuss about irrational numbers. So, what are the rational numbers and what are the irrational numbers? This we learn in previous classes. Again, we recapitulate what number systems we discuss in our previous classes. See here, the first one, set of natural numbers. Set of natural numbers. Set of natural numbers are represented with capital N. Capital N. So, this is a representation of a set of natural numbers. Set of natural numbers are represented with capital N. And so, what numbers, so what type of numbers this set of natural numbers consist? So, the set of natural numbers, in the set of natural numbers, so starts from 1, 2, 3, 4, 5 and so on. So, this type means from 1 to infinite. So, these numbers are there in set of natural numbers. In this set of natural number, the least number we can say, which one is the least number? The least number is 1. 1 is the least number. And which one is the highest number? If I say highest number is 99, then other boy he stand and say 100 is also there, no sir. If I say 999, one of the boy stands and he says 1000 is also there, no sir. If I say so 9999, so one of the boy stands and he says, sir, 10,000 is also there, no sir. So, that is why the last means the highest number. So, what is the highest number? So, we cannot say. So, that is undefined. The highest number is undefined in set of natural numbers. So, in set of natural numbers, the least number is 1, then highest number is undefined. So, in the set of natural numbers, these numbers generally we are using in our daily life. So, when we are going to purchase something, so how to add? 2 chocolates, we are going to purchase 2 chocolates at a price of 2 rupees each. Then what is the cost? Then how to multiply? So then all this in our daily life we are using these numbers. How to add, how to subtract, how to multiply and how to divide. So, these 4 fundamental operations we know very well, how to add, how to subtract, how to multiply and how to divide. So, these fundamental operations, so we can easily do. So, then after that, set of natural numbers. So, which set so we learn? So, after this, set of whole numbers. Set of whole numbers. Set of whole numbers. Set of whole numbers are represented with the letter capital W. Capital W. So this is set of natural numbers, set of whole numbers, set of whole numbers. The set of whole number is represented with capital W. So what type of numbers there in the set of whole numbers? So this set of whole numbers starts with 0, 0, 1, 2, 3, 4, 5 and so on up to infinite. So here, if we compare set of natural numbers and set of whole numbers, only one minor difference is there between set of natural numbers and set of whole numbers. That minor difference is there. What is the minor difference? That is 0 is there in set of whole numbers and 0 is not there in set of natural numbers. So that is the difference between set of natural numbers and set of whole numbers. So that is the minor difference between set of natural numbers and set of whole numbers. So then if 0 is there in set of natural numbers, so with using 0, then how to add, how to subtract, how to divide, how to multiply, so that we learn in our previous classes. So what we learn? So 0 plus 4 is how much? 0 plus 4 is 4. Then 0 minus 4, 0 minus 4 is minus 0 plus 4 plus 0 is 4. 0 plus 4 is also 4, 4 plus 0 is also 4. Then after that, so 4 minus 0, 4. So 0 minus 4, in the lower classes we do not know, so how to minus 0 minus 4. So 0 is a smaller number and 4 is a bigger number. From smaller number to bigger number we cannot make minus. So after that in 7th class we discuss, so we learn 0 minus 4 is what? When integers are there, then how to subtract, that we discuss. That is 0 minus 4 is minus 4, we will get minus 4. So with the 0, how to add, how to subtract, then how to multiply. So 4 into 0, 4 zeros are 0, 0 into 4, 0 4s are 0. So this also we discuss. So if we multiply 0 with any number, the product is 0. If we add any number with 0, the same number you will get. If you divide with 0, so 0 divided by 4 is 0, 4 divided by 0 is undefined. So this we discuss. So when 0 will come, then what are the properties? When you add with 0, when you subtract with 0, when you multiply with 0 and when you divide with 0. So all these concepts we discuss. Okay. So this we learn in our previous classes. The number system, so that is set of whole numbers. Then after that, so set of integers. Set of integers are represented with capital Z or capital I, any one letter. Capital Z or capital I. Set of integers are represented with capital Z or capital I. So what are the numbers are there in set of integers? In set of integers we have negative numbers, minus 3, minus 2, minus 1. 0, 1, 2, 3 and so on. So these numbers are there in set of integers. In the set of integers, in the middle, so we have 0. So at left side 0 left side negative values. So 0 right side positive values. So here, so in the middle, so 0 left side negative values, 0 right side positive values. So what are the numbers there in set of integers? Set of integers, negative numbers, positive numbers including with 0. So all the numbers present in set of integers. In the set of integers, what we discussed in our previous class, how to compare if two negative integers are given, if two positive integers are given. So negative with 0 is given, positive with 0 is given, and one negative and positive is given. So then how to compare which one is the least and which one is the highest, that we discuss in previous classes. And also we learn how to add integers, how to subtract integers, how to multiply integers, how to divide integers, these 4 fundamental operations. So about the 4 fundamental operations we discuss in our previous class. Okay. So these 3 number systems already we discuss. Now then after that, so which number system we learn? So the number system we learn is set of rational numbers. Set of rational numbers. Set of rational numbers are represented with Q. Set of rational numbers represented with Q. So what is mean by Q? Means what type of numbers are there in set of natural numbers? In the set of natural numbers, the numbers which are in the form of P by Q, the numbers which are in the form of P by Q, where Q is not equal to 0. This condition is there, where Q should not be 0. Q means the denominator should not be 0. So why the denominator should not be 0? About 0 property we discuss. 4 divided by 0, 4. Here 4 divided by 0. Divided by 0 means 4 by 0. If 4 by 0 means 4 divides 0, then that value is undefined. So that is why Q should not be 0. If the denominator is 0, the value is undefined. So that is why the condition is there, Q should not be 0. Q should not be 0. The numbers which are in the form of P by Q, all that numbers are rational numbers. All that numbers are rational numbers. So if I ask, so what about the 0? 0 is a rational number? No doubt 0 is a rational number. So why 0 is a rational number? It is not in the form of P by Q. So it is in the form of P by Q. There is no by, means by 1 is there. That is 0 by 1. 0 by 1, it is in the form of P by Q. So that is a rational number. So if I ask what about minus 2? Minus 2 is a rational number? No doubt is a rational number. Minus 2 is also a rational number. If a number is given, so if there is no by, means by 1 is there. By 1 is there. It is minus 2 by 1. Minus 2 by 1, it is in the form of P by Q. So that is rational number. That is rational number. So if I ask 0.9, either this number is a rational number, decimal number, no doubt decimal number is a rational number. How it is a rational number? After 1 point we have a decimal, then how to convert this into fraction, that is 9 by 10. We should divide with 10. So then the decimal will, so means this 0.9, that decimal will convert into fraction. So that is 9 by 10. Then decimal will convert into P by Q form easily. So decimal numbers are rational numbers. Then if I ask root 9, what about root 9? Root 9 is also a rational number. How? Root 9 means 3 3s are 9. Square root 9 value is 3. 3 we can take 3 by 1. 3 by 1 means that is P by Q form. P by Q form numbers are rational numbers. So what type of numbers are rational numbers? So here see, all natural numbers are rational numbers. All whole numbers are rational numbers. All integers are rational numbers. All decimal numbers are rational numbers. All terminating decimals are rational numbers. Non-terminating decimals are rational numbers. Perfect square numbers are rational numbers. So all these numbers are rational numbers. All these numbers are rational numbers. So what? Natural numbers, whole numbers, integers. Then after that, so decimal numbers, in decimal numbers, terminating decimals, non-terminating decimals. In square root, the numbers which are having a perfect square root values, that numbers are rational numbers. Okay. So all these numbers are rational numbers. The numbers which are in the form of P by Q, they are rational numbers. So this is the important definition. What rational numbers means? If a number is in the form of P by Q, then that is a rational number. Then what about irrational numbers? Irrational numbers after last. So irrational numbers are represented with q dash. Irrational numbers are represented with q dash. So, rational numbers are represented with q and irrational numbers are represented with q dash. Then what is the difference between rational and irrational numbers? So, the numbers which are not having a perfect square root values, so they are irrational number, not perfect square root numbers, like root 11. So, root 11, it is not having a perfect square root value. So, root 19 under root 3. So, this type of numbers, the numbers which are not having a perfect square root values, so they are irrational numbers. And which type of numbers are again irrational numbers? This is about perfect square root values. And other than that, so the numbers which are neither terminating nor not terminating decimals, so that type of decimal numbers are irrational numbers. Okay. So, like if I take decimal number 1.73902659, it continues like this. So, here there is no perfect pattern is there after decimal. If perfect pattern is not there and it continues infinite times, so these type of numbers are irrational numbers. So, perfect pattern. So, what mean by perfect pattern? If suppose if I in decimal number if I take 1.12121212, here 121212 repeats. Here perfect pattern is there. So, what is the perfect pattern here? 12121212. This is non terminating decimal. So, this we can convert into rational form. So, this is neither terminating nor non terminating decimals. So, these type of numbers are irrational numbers. Irrational numbers. So, what type of numbers are irrational numbers? Irrational numbers are the numbers which are not having perfect square root values. They are irrational numbers, and also the numbers which are neither terminating nor non terminating decimals. That type of numbers are irrational numbers. Okay. This is about our number system, what we learn till 9th standard. See here, first set of natural numbers, set of whole numbers, set of integers, set of rational numbers, and till here we have a relation between the sets. So, what relation is there? See here, if once we observe set of natural numbers and set of whole numbers, here 1 2 3 4 5 are there, here 1 2 3 4 5 numbers are there in the next set. Here, so if you take whole numbers and integers, in whole numbers, so 0 1 2 3 4 0 1 2 3 4 elements are there. So, whatever elements are there in set of whole numbers, that elements present in set of integers. Whatever elements present in set of natural numbers, that elements are there in whole numbers. And after that, whatever elements present in set of integers, that all elements should be there in set of rational numbers, So, now here, here set of natural numbers, set of whole numbers, set of integers, set of rational numbers. So, these sets have a relation between them. So, what relation? So, all the set of natural number elements means numbers that presents in set of whole numbers, and in set of whole numbers whatever the numbers there, so that present in set of integers, and whatever the numbers present in set of integers, so that all numbers present in set of rational numbers. Where, sir? Say if you ask, here p by q means minus 3 by 1, minus 2 by 1, minus 1 by 1, 0 by 1, 1 by 1, 2 by 1, 3 by 1, means by 1 is there. So, it means, set of integers, all set of integers are rational numbers that we discuss. Other than that, decimal numbers and fractions, all fractions, like fractions, unlike fractions, so proper fractions, improper fractions, mixed fractions, all that are rational numbers, and decimal numbers, terminating decimals, non terminating decimals, and perfect square root values. All these numbers are rational numbers, and irrational numbers, the numbers which are not having perfect square root values, and the numbers which are not having, the numbers which are which neither be a terminating nor be a non-terminating. So that type of numbers are irrational numbers. Now after that, now our chapter is real numbers. So what about real numbers? So real numbers, what type of numbers are real numbers? The real numbers are the numbers which are rational and irrational numbers. Rational and irrational numbers. So rational and irrational numbers are real numbers. Rational numbers and irrational numbers are real numbers. That means q plus q dash. Q means rational numbers. Q dash means irrational numbers. Rational and irrational numbers are real numbers. So what are rational and what are irrational numbers? So once again, rational numbers, all natural numbers, all whole numbers, all integers, all fractions means proper fraction, improper fractions, like fractions, mixed fractions. So all fractions and decimals. In the decimal, terminating and non-terminating decimals, and in square root, the numbers which are having perfect square root values. So all these numbers are rational numbers. So what about irrational numbers? The numbers shall neither be a terminating nor be a non-terminating decimals. That numbers are irrational numbers, and the numbers which are not having perfect square root values. So that are irrational numbers. So our real number, the next number system is real numbers. Now in this class we are going to discuss about real numbers. In the real numbers, the combination of rational and irrational. Rational and irrational numbers are real numbers. Okay students, now today in this class we are going to discuss about real numbers. Okay. Yes students, see here. So natural numbers, set of natural numbers are subset of whole numbers. Whole numbers are subset of integers. Integers subset of rational numbers. So first, set of natural numbers. This is about set of natural numbers. Set of natural numbers are subset of set of whole numbers. Set of whole numbers are subset of set of integers. Set of integers are subset of rational numbers. So set of rational numbers. So now here irrational numbers. Irrational numbers. Irrational numbers are represented with q dash. Rational numbers are represented with q. Natural numbers are subset of whole numbers. Whole numbers are subset of integers, and integers are subset of rational numbers. So rational numbers are represented with q and irrational number. So this rational numbers and irrational number. So rational plus irrational, real numbers. Real numbers. Rational plus irrational. Rational plus irrational. So this is about our irrational. Rational plus irrational is equal to real numbers. Okay. So this is the concept about our number system. Set of natural numbers, set of whole numbers, set of integers, set of rational numbers, set of irrational numbers. Then after that, our chapter is set of real numbers. So what about set of real numbers? So real numbers are the numbers which are rational and irrational. So rational means natural numbers plus whole numbers plus integers plus terminating decimals plus non-terminating decimals plus perfect square root values, perfect square roots plus fractions, all fractions. So all these are rational numbers. All these are rational numbers. And irrational numbers are the numbers which are neither terminating nor non-terminating. Neither terminating nor non-terminating decimals, which are not perfect square root numbers. So this is about irrational numbers. All these numbers are our real numbers. All these numbers are real numbers. If anybody asks what are the real numbers, square root, perfect square root. So numbers are real numbers and fractions also real numbers, and which are neither terminating, non-terminating also real numbers, and the number which are not having perfect square root values are also real numbers. So the combination of all these numbers are our real numbers. So simply rational numbers and irrational numbers are the real numbers. Okay? Yes, students. Yes, now students. So here, so Leopold Knopfler. So what he said, God made the integers. God made the integers, and after that, all else is the work of man. So God made the integers. Integers already we discussed. What are the integers? So negative numbers, positive numbers, including in zero. So God made the integers, and all else is the work of man. So whatever work means, so how to add, how to subtract, how to multiply, and how to divide. So this all the things man did. So in this, generally in our daily life, the number system is very important. How? So when a baby born, so at what time he born, what date he born, so that we calculated. So the number system is very important in our life. So that's what he said, God made the integers. God made the integers. All else is the work of man. All else is the work of man. So what is the work? Then how to add, how to subtract, how to divide, and how to multiply. All these fundamentals. So what are the rules and regulations, and what is the system, how to add integers, how to subtract integers, and what is the method. So that work, all that work, so that work is a man's work. That is man's work, he said. Who said? Leopold Knopfler. So he said. Okay. Then after that, in this real number system, so we are going to discuss an example. So what is the example? See here. So that we generally using in our daily life. What is there? See here, in a garden. So in a garden, some swarm of bees were there. Some bees were there in a garden. So a puzzle. So that puzzles also in our daily life, we are using puzzles. We are doing puzzles also. This is one kind of a puzzle. What is there? So in that puzzle, the span of bees divided into 5 groups. Suppose, so whatever the span of groups are there, so that divided into 5 groups. So total bees is equal to 5q plus 0. 5q plus 0. So where this q is a natural number. Q is a natural number. Which number? Natural number. Okay. Here, the next, if total bees are divided into 4 groups, so the total bees is equal to 4b plus 3. So here b is a natural number. B is a natural number. So any natural number, 1, 2, 3, 4, 5, 6, 7, whatever. So that we should find. Then if total bees divided into 3 groups, the statement will come 3c plus 2. Here c is a natural number. If suppose all the bees are divided into 2 groups, then the total bees is equal to 2d plus 1. So here d is a set of natural number. From the set of natural number, the d will come. The first is, if total bees divided into 5 groups, the mathematical statement is x total bees is equal to 5q plus 0. In the second one, if total bees are divided into 4 groups, the mathematical statement, that is total bees x is equal to 4b plus 3. Here b is from set of natural number. If total bees divided into 3 groups, the mathematical statement is x is equal to 3c plus 2. If total bees divided into 2 groups, then total bees is equal to 2d plus 1. Here 0, 3, 2, 1. 0, 3, 2, 1. 0, 3, 2, 1. 0 is less than 5. 0 value is less than 5. 0 is less than 5. 0 is less than 5. Here 3. 3 is less than 4, 3 is less than 4, and after that here 2 is less than 3, 2 is less than 3, and after that 1, this one is less than 2, 1 is less than 2. Okay, so here 0 is less than 5, 3 is less than 4, 2 is less than 3, and 1 is less than 2. Okay, this you should remember. 0 is less than 5, 3 is less than 4, 2 is less than 3, 1 is less than 2. It means all these are reminders. All these are reminders. It means remainder is always less than the divisor. Remainder is less than the divisor. So how it is less than the divisor? Suppose if 5 divided by 2. So then how to divide that we know. See here, 2 divided by 5. Here 2 is a divisor, 2 is a divisor. Now we have to check intuitively when we get 5, 2 2s are 4, 2 2s are 4, and the remainder is 1. The remainder, this remainder is always less than the divisor. The remainder is always less than the divisor. So that is why 1 is less than 2. So it means here 0, 3, 2, 1. All these are remainders. So when we divide by 5, then the remainder is 0. So when the group is divided with 4, divided into 4 groups means when we divided with 4, the remainder is 3. When we divided with 3, the remainder is 2. When we divided with 2, the remainder is 1. It means. So then what is the number? So that number we have to find. See here. So for the puzzle first we should use our brain. So what? How to get the number? Here, so 5. 5 cube plus 0. Here 0 means 5 exactly divides. 5 exactly divides the number. When remainder is 0, that means 5 exactly divides the number. Then after that, here the last one, 2d plus 1. Here 2 divides the number and remainder is 1. Means odd number. Here 5 exactly divides. 5 exactly divides. Here the remainder is 1. Here odd number. So on the basis of these two combinations, we should select a number. So the number should be exactly divided with 5 as well as that number is the odd number. So in the 5 table, so such numbers we should select. So what is the multiples of 5? 5 1s are 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25, 5 6s are 30, 5 7s are 35, 5 8s are 40, 5 9s are 45, such number. These all are multiples of 5. In these multiples, so we should take 5. So we took 5 multiples. In that, odd numbers we have to select. Odd numbers we have to select. Odd numbers. 5 is an odd number, even number. Don't take 10. Then 15 odd number we should take. And 10 even number, don't take. 25 odd number, so that you should take. And after that 30, you should take 25, don't take even number, and take odd number, don't take even number and odd number. In this number, one number should be there here. So on the basis of these statements, we should select a number. How? Here on the basis of first statement, the number is a 5 divisor, 5 multiple, that is 5 cube plus 0 means 5 multiples. So and in the last statement 2d plus 1 means that is the odd number. The number is an odd number as well as the 5 multiple. Such numbers we have to select. And after that we should take using a trial and error method. So here 35 suits our answer. How it is? Now, so from first statement x is equal to 5 cube plus 0. 5 cube plus 0. If you take 35 here, Then how you will get 35? 5 sevens are 35 plus 0. So 35. 5 sevens are 35 plus 0. 5 sevens are 35 is equal to 35. Here it satisfies. When you take 35, then the first statement satisfies. Now, if you want to take second, what is the second statement? So the second statement is equal to x is equal to 4b plus 3. What is our x? X is 35. We should take again 35x. Total b is 35. Then 4. 4 8s are 32 plus 3. 4 8s are 32. 32 plus 3. 32 plus 3, 35. 35 is equal to 35. Second statement satisfies. Third statement. So what is the third statement? Our third statement is x is equal to 3c plus 2. X is equal to 3c plus 2. Now here x or x total b's, how many b's we are taking? 35. Total b is 35 is equal to 3 into 11 plus 2. 3 11s are 33 plus 2. Here 35. 35 is equal to 33 plus 2, 35. Total is 35 is equal to 35. It satisfies. Here also 2d plus 1, here also it satisfies in the fourth statement. If you want to check fourth statement, again you should take and check. X is equal to 2d plus 1. So x 35. Take x as 35. 2, 12. 12. So in 2 table, 2 14s are 2 14s are not 2 14s are 18 plus 1. So 18, 17, you should take 17 here. 2 17s are 34 plus 1. 34 plus 1, 35. 35 is equal to 35. So in 4 statements, in all these 4 statements, so 35 satisfies. It means how many bees are there in the park? Total 35 bees are there, which satisfies these conditions. When 35 bees are there in the park, then when we divide it into 5 groups, so no bees were left. When divided into 4 groups, then 3 bees were left. When divided into 3 groups, 2 bees were left. When divided into 2 groups, then 1 bee will left. So according to that, this puzzle, so we solve it this way. First we should think on the basis of this mathematical statement what he has given. First we think that. So in the first statement 5 cube plus 0 is given. It means 5 cube plus 0. It means 5 exactly divides the number. It means 5 multiples we should take. In the second statement 4b plus 3. When we divide into 4 groups, then 3 b's were left. So in the third statement, when we divide into 3 groups, then 2 b's were left. When divided into 2 groups, then 1 b is left. Then after that you take the second last statement. It is a very easy one to decide which number will come. So 2d plus 1. 2d means when we divide with 2, so 1 is left. That means odd number will come. So all in 5 multiples, only odd numbers we should select. 5, 15, 25, 35, 45. And one by one you check, you keep in these statements and check. So 35 number that satisfies all these statements. So in our puzzle, how many bees are there in the park? 35 bees were there in the park. Okay, these type of puzzles, maths puzzles we can solve. Here one thing we should remember. So when we divide any number, the remainder is always less than the divisor. The remainder is always less than the divisor. If divisor is 5, then the remainder is always less than 5. So what number will come? 4, 3, 2, 1, 0. These numbers will come. Okay, these you should keep in your mind. When we divide any number, the remainder should be always less than the divisor. Okay, students, see here. So before going to explain the division algorithm here, so I want to explain a problem with example. See here. So what is that? If 5 divided by 5, then what happened? If 6 divided by 5, what happened? If 7 divided by 5, what happened? If 8 divided by 5, what happened? If 9 divided by 5, what happened? If 10 divided by 5, what happened? See here one by one. 5 divided by 5 here. If 5 divides 5, 5 ones are 5. The remainder is 0. So if 6 divided by 5, so it means 5 divides 6, 5 ones are 5, the remainder is 1 if we subtract. If suppose 5 divides 7, 5 ones are 5, the remainder is 2. Here, if 5 divides 8, 5 ones are 5, the remainder is 3. If 5 divides 9, 5 divides 9, then 5 ones are 5, the remainder is 4. If 5 divides 10, then 5 twos are 10, remainder 0. See here, so when we divide with 5, in all the cases we divide with 5, 5, 5, 5, 5, 5. So when we divide with 5, when divisor is 5, when the divisor is 5, then what are the reminders? The remainder is 0, remainder is 1, remainder is 2, remainder is 3, remainder is 4, again 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So like this reminders will come. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. When we divide with 5, divisor is 5, then the reminders are 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So when the divisor is 6, the reminders are 0, 1, 2, 3, 4, 5 till 5. Reminders are 0 to 5. So when the divisor is 7, the reminders are 0 to 6. 0 to 6. So when the divisor is 8, the reminders are 0 to 7. So it is like that. So when the divisor is 5, the reminders are less than or equal to 0 and less than or equal to 4. It means from 0 to 4, the reminders are from 0 to 4. Reminders are 0 to 4. So once again see here. So when we divide 5 with 5, the remainder is 0. When we divide 5 with 6, then the remainder is 1. Then 5 divides 7, the remainder is 2. 5 divides 8, the remainder is 3. 5 divides 9, the remainder is 4. Again 5 divides 10, the remainder is 0. Then what are the remainders here? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. It continues like that. It means when the divisor is 5, then what are the remainders? 0, 1, 2, 3, 4. Total 5 remainders we will get. That is from 0 to 4. When divisor is 5, then the remainder R means remainders are from 0 to 4. When the divisor is 6, so then the remainders are from 0 to 5. So when the divisor is 7, the remainders are 0 to 6. So this is the, so generally understood when the divisor, it depends on the divisor. If divisor is 10, the remainders are from 0 to 9. If the divisor is 13, the remainders are from 0 to 12. 0 to 12, total 13 remainders we will get. So because 0 is also included. So when the divisor is 20, so we should get 20 remainders, that is from 0 to 19. This you should remember. So about the divisor, so what is the divisor? First we have to check. According to the divisor, what the remainders we will get, that we have to check. So like this, when 5 is a divisor, we have 5 remainders, that is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. All these 5 reminders are less than the divisor. So that is why the reminders are from 0 to 4. Symbolically how to write? 0 is less than or equal to R is less than or equal to 4. So it means remainder is in between 0 to 4. Okay.